Back in 2011, a massive earthquake and tsunami struck Japan, triggering one of the worst nuclear disasters in modern history. The Fukushima Daiichi power plant went into meltdown, releasing radioactive material that contaminated the land, the air, and the water. It was a catastrophe on an epic scale. But one of the biggest, most persistent problems was invisible. Deep underground, groundwater was flowing through the contaminated reactor site, mixing with radioactive substances and then seeping continuously into the Pacific Ocean. This was a slow-motion environmental crisis. And for years, engineers at the Tokyo Electric Power Company, or TEPCO, struggled to contain it. They tried pumping the water out, but it just kept coming. The scale of the problem was immense, with hundreds of tons of contaminated water being generated every single day. They needed a solution, and they needed one fast. What they came up with sounds like something straight out of a science fiction movie. Their plan was to build a giant, underground wall of ice. That's right, a massive, frozen barrier to hold back the contaminated ground. The official name for this project is the Landside Impermeable Wall. The idea was to freeze the very earth around the damaged reactor buildings, creating a solid, impermeable barrier. Think of it like a massive underground dam, but instead of concrete, it's made of frozen soil. This wasn't just a simple freezer job. It was one of the most ambitious and complex engineering projects ever attempted. To make it happen, they drilled over 1,500 holes deep into the ground, forming a 1.5-kilometer-long perimeter around the reactor buildings. Inside each hole, they inserted a long steel pipe. These pipes acted like giant straws, but instead of sucking things up, they were designed to deliver extreme cold. A massive refrigeration plant, powerful enough to cool a small city, was built on site. It pumped a special brine coolant, chilled to a frosty -30°C, through this vast network of underground pipes. The goal was to slowly but surely freeze the surrounding soil solid, creating a continuous wall of ice about 30 meters deep. It was a monumental undertaking that took years and cost over $300 million. Top scientists and engineers from across Japan were brought in to oversee the project. The process was slow and deliberate. They had to freeze the ground section by section, carefully monitoring the temperature to ensure the wall formed correctly without any gaps. Finally, in 2016, the ice wall was officially activated, and for a while, it seemed to work wonders. The amount of groundwater flowing into the contaminated areas dropped dramatically, from hundreds of tons a day to just a fraction of that. It was hailed as a major success, a testament to human ingenuity in the face of an unprecedented disaster. The ice wall was effectively creating a frozen fortress around the radioactive core of the problem. Buying precious time for the long and difficult cleanup process, it was a huge relief for everyone involved. But here's the thing about trying to control nature with technology. Nature always finds a way to push back. The ice wall was never meant to be a permanent solution. It's more like a very expensive, very complicated band-aid. The system requires an enormous amount of electricity to run continuously, 24 hours a day, 365 days a year. If the power goes out, the wall starts to melt. And even with the power on, it's a constant battle against the elements. Rising ground temperatures, especially during the warmer summer months, have caused parts of the wall to thaw unexpectedly. Engineers have had to work around the clock, drilling new pipes and injecting special materials to plug the leaks and reinforce the melting sections. It's a high-stakes, never-ending maintenance job. They are constantly innovating, trying to make the wall more resilient and efficient, but it's a race against time and temperature. The ice wall is an incredible piece of engineering, a symbol of human resolve, but it also highlights the sheer difficulty and scale of cleaning up a nuclear disaster. So, where does that leave us? The Fukushima ice wall is still standing, still freezing, still holding back the tide of contamination. It's a surreal, invisible monument to a crisis that is far from over. The real work of decommissioning the plant, of removing the melted nuclear fuel, will take decades. The ice wall has bought them time, but the fundamental problem remains. This story leaves us with a profound question. Can we truly contain the consequences of our most powerful technologies with brute force engineering? Even something as audacious as a giant ice wall? Or are we just temporarily delaying an inevitable environmental reckoning? The frozen wall of Fukushima stands as a powerful, chilling reminder that sometimes the most challenging battles are the ones we fight against our own mistakes. Deep beneath the surface. Thanks for watching. If you found this story interesting, consider subscribing for more deep dives into science and engineering. See you next time.